All right, we're looking at dilations day 2 homework, dilations in the coordinate plane. Okay, so what we're going to do is we're going to, given the triangle ABC shown, graph its image after a dilation centered at the origin. Well, here's the origin. Okay, why it tells us that in the scale factor of 2 is because the distance from C from the origin is going to double to get to C prime, right? So before I can even dilate this, we know it's going to get twice as big, but I probably should know all the coordinates for A, B, and C before I can double them. Okay. So if I look at A, it has the coordinates of -4, -4. B has the coordinates of -4, -3. And I do apologize, that's not -4, -4. That's -4, +4. This is -4, -3. And C is 4, -3. So +4 and a -3. Now remember, when you see this word scale factor, it means to multiply. So this image is going to get twice as big. So I want to find out what A prime is, B prime, and C prime so that I'm able to actually multiply them. And then I can plot them on the grid. Okay, so multiply both by 2. Multiply both by 2. Multiply both by 2. Now, as you plot this, you're going to be able to clearly see which lines are parallel for the next question. So I'm only going to plot 2 of these points, so that way I can make the connection with you. -8, -6 for B is -8, -6, there's B prime. And C is 8, -6. Here's C prime. So this is the bottom part of the triangle. Okay, you need to do A and get the other 2 sides. So what we can see is that BC is going to be parallel to B prime, C prime. It matches up. You should have 2 more segments to be able to write that are going to be parallel. I'm going to leave that one as that. Okay. Now to move on to exercise number 2 or 3. It says the line containing the points -2, 10 and 7, 4 is dilated by a scale factor of 2. Okay, again, it's going to get twice as big. You can start off by plotting them, -2, 10 and 7, 4. So if I connect it, this is the original. This is the pre. This is the pre-image. Now this thing is going to get twice as big, which means it's going to go off my graph. But I'm going to keep reading. Then the slope of the new line would be which of the following? So we just learned that the pre-image and the dilated image should be parallel. And we saw that up here. Okay. So you simply just need to be able to find the slope here. And whatever you get the slope for here, yes, it's going to be doubled, but then it's going to reduce because they're supposed to be parallel. So remember, parallel means that they need to have the same slope. Now your questions on the back of this page are not truly assigned to you unless you would like to do extra credit. Okay. Now here in this one, they plotted it for you and then they told you they actually gave you a scale factor. So we have to find and plot its image after a dilation, again with the center at the origin, and then a scale factor of 1/2. So that means you would take both of these coordinates and multiply them by 1/2 to get the new ones. Now the rest of this problem should be easy for you if you're attempting this as extra credit. Okay. So it would become -2, 2, and b prime would become 4, 4. So you actually want to plot that on your grid. Okay. And then answer B, if we're showing that they're parallel, hopefully remember parallel means the same slope. And you should be able to use, if you're using coordinate geometry, show that A prime, B prime is half of AB. Well, you need the distance formula to do that. Okay. Second one's a little bit harder. Okay. It says that EF is the image, so this one is the image. So that means that BC is the pre-image. With an unknown center and an unknown scaling factor. Okay. So first we got to figure out the scale factor. Alright, so I'm going to kind of take a look at the slope of these lines. The rise and the run may be able to help me determine the scale factor. This has a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. EF has a rise of 12 and a run of 1, 2, 3, 4, 5, 6, 7, 8. BC has a rise of 1, 2, 3, 4, 5, 6, has a rise of 6, and only a run of 1, 2, 3, 4. So right here we should be able to see that this clearly the scale factor is 2 because it's twice as big. Okay? So the scale factor is 2. Okay, now it wants us to be able to determine the center point graphically. So if I look at this graph, now with this it can be a little tricky, but if you understand slope, you should be able to figure it out. Okay. Now both of these should both lead back to the same exact point. So to get from F back to C, it was a drop of 1, 2, 3, 4, 5, and back 1, 2. Now since this is a scale factor of 2, I only have to do that twice. I already did it once, so now if I go down 1, 2, 3, 4, 5, and back 1, 2, it looks like my center of dilation might be right there, but I'm going to check it according to here. Now to get from E to B, I rose 1 and went back 1, 2, 3, 4, 5, 6. So that means I should do it again. Rise of 1, 1, 2, 3, 4, 5, 6. Yep. They both get back to the same point. Now if I was to connect EF as such, FC, and I was to connect EB, this is the other way to do it besides using slope. If I was to connect them, you could see that they all lead back to this this intersection point here. So I drew a line here and I drew a line here, and they led back to that center point here. Okay, so that's how you figured it out graphically, so you should be able to get that there. Alright, if you have any further questions, please ask in class.